So let's talk about stereochemistry of Sn1 and Sn2. I got you started with a little bit of stereochemistry last day. Basically, I told you the result, which was in Sn1 with a given Fisher projection, where say this carbon has 4 different drugs, and thereby chirality when treated with Y minus, if the mechanism is Sn1, expect what's called optical retention as well as what's called optical inversion, and the two happening together is basically supposed to be an act of racemization. So you know about racemic mixture. The two are enantiomers having equal and opposite optical behavior. Now the first one is supposed to be the case of optical retention because you could see the Fisher projection is exactly like that of the reactant. So in one way, the chirality or the arrangement of groups around the chiral carbon has been retained. Retained, so I'll call it retention. And naturally, the term inversion will also bear its literal meaning because in inversion, you exactly see the inverted or the mirror image of the retention product. Naturally, in the mechanism of Sn1, in the slow step, with the loss of X minus, we are expecting a carbocationic intermediate. Now, naturally, this carbocation and this carbon is sp2, flat planar. Realize this is sp3, this is also sp3. So one tetrahedral is forming a carbohydrate, is forming a carbocation which is flat planar, and then attack of Y minus, and realize because this is flat planar, Y minus could attack both from above and behind the tail of the board. Let me take this whiteboard as the frame of reference. Or let's say this is the plane mirror across which I'll have one particular Fisher projection, tetrahedral, and its mirror image. Now, very quickly, if I do it this way, please hear me out. If suppose this is one tetrahedral, I think this is being captured in the camera as well. People online will want to respond. See, this is the tetrahedral. बच्चे लोग ध्यान से देखो, ये टेट्राहेड्रल को मैं ऐसे प्रोजेक्ट कर रहा हूँ. अरे हाँ ना बोलो, हाथ दुखने लग जाता है ऐसे चार्जर मार के पकड़ने से. इस टेट्राहेड्रल को मान लो मैं ऐसे दिखा रहा हूँ. And if this whiteboard is suppose the mirror, the plane mirror, if this whiteboard is suppose the plane mirror, then if this is one particular tetrahedra, its mirror image or its enantiomer in the plane mirror would look like this. All right. Say you want me to be the observer. This is how I see it as the object, and the same when viewed in the plane mirror, इसका lateral inversion के बाद में इसका जो image मेरे को plane mirror में मिलेगा, it would look like this. Yes or no? I would want you to speak with a little make sense.
Yes, sir.
दिस इज नॉट हार्ड टू इमेजिन, दिस इज एज सिंपल एज इट साउंड्स कि इसका प्लेन मिरर अगर व्हाइट बोर्ड है तो इसका प्लेन मिरर में जो इमेज दिखेगा वो ऐसा दिखेगा। सपोज ये लीविंग ग्रुप है, ये लीविंग ग्रुप है, ये एक्स है। जब ये एक्स निकल जाता है, ये एक्स निकल जाता है, तो मैं बोलता हूं ये फ्लैट प्लेन कार्बोकेटायन बन जाता है। फिर हाँ नानी बोलते हैं। अब इस फ्लैट प्लेन कार्बोकेटायन में where the three arms are on the plane of the plane mirror only, or which are on the plane of this whiteboard only, y minus could attack either from above and give you retention, yes or no, or it can attack from behind and give you inversion. Obviously, मेरे को पता है, 2-3 बार रिपीट करवाओगे। द मोमेंट आई टोल्ड यू कि इससे मेरे हाथ में दर्द होता है, न्यू दैट यू नो यू आर गोइंग टू टेक योर टाइम। सो not a problem, I'm kind of mentally prepared for it. And if this is one tetrahedral and this is the plane of the whiteboard or the mirror, the image of this object in the mirror is supposed to look like this. Obviously, if I take this as the leading group, if this is lost in the slow step, I'll have a flat carbocation on the plane of the mirror or on the plane of the board. अब ये फ्लैट प्लेनर है। अब y माइनस अगर इसके ऊपर से आके अटैक करता है तो रिटेंशन जैसा बन जाएगा, और अगर इसके बोर्ड के पीछे से आके अटैक करता है तो इसका मिरर इमेज जैसा बन जाएगा। यस और नो? यस और नो?
हाँ सर।
चलो, हालांकि इसमें उतना विजुअलाइजेशन भी नहीं है। जनरली पीपल रिस्पॉन्ड in most of the batches with more conviction. Nevertheless, I'll not doubt your intellect. I think you have understood me so far. This is the maximum I was willing to, express, and it's simple as it looks. Because of the flat planar carbocation, y minus can attack either from above or from below and would give you a pair of enantiomers. Will give you a pair of enantiomers. Yes or no?
Yes, sir.
Yes.
Sn1 causes racemization. Sn1 causes racemization. Sn1 causes racemization. But not 100%. But not 100%. What would be a 100% racemic mixture? A 100% racemic mixture will have optical activity 0. And when will that happen? When will the racemization be 100%? Racemization will be 100% when the two are exactly equal. When inversion is equal to retention. Now please hear me out. ये स्लो स्टेप है और ये फास्ट स्टेप है। इसका निकलना स्लो है और अटैक करना फास्ट है। So it would make sense if I tell you, that while all of this is happening, slow step में x minus धीरे धीरे निकल रहा है, although it's flat planar and both possibilities coexist, because x minus is leaving gradually, slowly, and is likely to be in the vicinity of this carbocation for a longer period of time, attack from behind the plane is more likely or is spherical more feasible. Yes or no?
Yes, sir.
ये स्लो स्टेप है, फ्लैट प्लेनर है, दोनों तरफ से लगने का चांसेस है, पर दोनों तरफ से लगने का चांसेस बराबर क्यों नहीं है? क्योंकि अगर ये धीरे धीरे जा रहा है x minus, it's likely to stay in the vicinity of this carbocation for a longer period of time, and the attacks from behind the plane is sterically and even electronically more feasible because this x minus and y minus will be repelling. Yes or no? ये स्लो है, x minus को जाने में थोड़ा टाइम लगता है, वाई माइनस जल्दी आके अटैक करता है। ऑल्दो ये फ्लैट प्लेनर है, ये तो ऑप्टिकली प्योर था ना, ये तो ऑप्टिकली प्योर था, ये तो एक पर्टिकुलर कंपाउंड था। ऑप्टिकली प्योर मतलब क्या यार, तो डिस्को या है, ये तो एक ही कंपाउंड, एक ही आइसोमर, एक ही स्टीरियो आइसोमर है। तो इससे अगर एक मिक्सचर बनता है, इससे अगर एक मिक्सचर बनता है, तो naturally it's leading to racemization. It's leading to racemization. What was initially optically pure in course of Sn1 would become a mixture which is pretty racemic in nature. But that racemization is not 100% because both electronically and sterically inversion is marginally favored. This is marginally favored. Yes or no? Or inversion will happen a little
Yes,
more
sir.
than, inversion will happen a little more than, inversion will happen a little more than retention. Inversion will happen a little more than retention. Yes or no? अब
Yes,
अगर
sir.
मान लो ये
Yes, sir.
कंपाउंड 1 है और ये कंपाउंड 2 है, मान लो ये कंपाउंड 1 है और ये कंपाउंड 2 है, और मैं तुमको बोलता हूं कि इसको ऑप्टिकल एक्टिविटी +40 डिग्री है, तो नेचुरली इसका ऑप्टिकल एक्टिविटी -40 डिग्री होगा। यस और नो? और ये जो मिक्सचर है, ये जो मिक्सचर है, ये जो मिक्सचर है, ये जो मिक्सचर है, अगर मैं बोलूं इसका ऑप्टिकल एक्टिविटी -4 डिग्री है, यू रिमेंबर आई टॉट यू अबाउट इनैंसियोमेरिक एक्सेस। मैं एक चीज सिखाया था इनैंसियोमेरिक एक्सेस में, क्या बोला था? हमेशा इनैंसियोमेरिक एक्सेस निकालने का एक फॉर्मूला होता है। इनैंसियोमेरिक एक्सेस का मतलब ही होता है कि दोनों इनैंसियोमर में एक इनैंसियोमर ज्यादा है। ये अगर +40 और ये -40 और नेट -4 आ रहा है, मतलब नेचुरली 2 1 से ज्यादा है। और कितना ज्यादा है वो निकालने के लिए कुछ नहीं करते, ये जो 4 है ना, इसको 40 से डिवाइड कर देते हैं और बोलते हैं 10% इनैंसियोमेरिक एक्सेस है। और अगर 10% इनैंसियोमेरिक एक्सेस है, इसका मतलब 90% रेशमिक है, मतलब 45% 1 है और 45% 2 है, और जो इनैंसियोमेरिक एक्सेस है इसको जोड़ देने से इट विल बी अ मिक्सचर ऑफ 45% 1 and 55% 2. Simple as it looks. Everything you do in numbers would look more authentic. तो ऐसा नहीं है that a problem will include everything which I have given you in the problem, but through both the theory, which is the qualitative understanding, and then with numbers here and there, you could see that in a case of Sn1, in a case of Sn1, the stereochemistry will be of optical inversion slightly favored over optical retention, which will mean Sn1 causing racemization is a correct statement, but it will not cause 100% racemization because inversion compound will always be a little more than the retention compound. But चलो हाँ ना बोलो।
हाँ सर।
ठीक है, यू आर हैप्पी विद दिस? I can rub it off. I can rub it off.
हाँ सर।
And what will happen in Sn2? What will happen in Sn2? What will happen in Sn2? अगर ऐसा है, And if it's happening via Sn2, it will be a case of optical inversion, which is also popularly called Walden inversion, और कभी कभी इसको umbrella inversion भी बोलते हैं. And it can be proved कि 100%. It can be proved कि 100%. It can be proved कि 100%. Now let me tell you an interesting fact. Percentage ratiomization was not challenging. We calculated percentage ratiomization because with a given optical activity and with optical activity of this pure component known, you can find what enantiomeric excess is basically like finding the mixture of net optical rotation of the mixture. तो इसके पहले वाले प्रॉब्लम में जो मेरा +40 -40 था ना, मैं पहला वाला को x लेकर के 40 into x plus minus of 40 into 100 minus x upon 100. You know, I could have taken it as -4. Yes or no? Yes or no? And I would have got x is equal to 45%, 100 minus x is equal to 55%. You're getting me? When I do it in terms of enantiomeric excess, I end up telling you a term, plus it looks a little elliptic. I mean, this is like more childish. But दोनों में हम लोग करते वही हैं. बच्चे लोग हाँ ना बोलो. +40 -40 पता है, +40 -40 पता है, नेट -4 पता है, तो हम लोग enantiomeric excess करके या ऐसा फॉर्मूला करके percentage ratiomization and everything can be dealt with. But tell me, how on earth do you prove 100% inversion? Because to prove 100% inversion, you want the optical activity to be completely inverted to the same extent. Yes or no? But these two are not enantiomers. You getting me? बात समझ में आ रहा है?
हाँ सर.
तो एक क्लासिकल एक्सपेरिमेंट है. There is a classical experiment which is there scripted in the history of, you know, and again these people, Ingold and his co-workers, they carried out an experiment. मतलब पूरा इन्वर्सन करने के लिए तुमको क्या करना होगा? x को x से रिप्लेस करना पड़ेगा, सब्स्टिट्यूट करना पड़ेगा, तभी तो कुछ प्रूफ कर पाओगे ना. पर x से सब्स्टिट्यूट कैसे होगा? जो भी है. तो to cut it short, they took two methyl, they took two iodooctane. So when you take two iodooctane, this is going to look like 1, 2, 3, 4, 5, 6, 7, 8. An iodine here and hydrogen here. It's optically active, yes or no? बच्चे लोग हाँ ना बोलो. फिशर प्रोजेक्शन में कैसा दिखेगा? फिशर प्रोजेक्शन में 2 iodooctane दिखेगा कि मान लो यहाँ पर मैं लगाया आयोडीनेट, यहाँ पर लगाया मैं हाइड्रोजन, यहाँ पर लगाया मैं CH3 और यहाँ पर 1 2 3 4 5 6 कार्बन का मैं C6H13 लिख दिया. ठीक है. अब ये iodine which is 127 was made to react with iodide which is 128. Isotopic labeling जैसा. तो नॉर्मल आयोडीन को हम लोग सब्स्टिट्यूट कर रहे हैं विद आयोडीन 128 and expect the product to be like this. With the problem that this will be pretty reversible. When iodide is substituting iodide, you could claim a heavier isotope would be having more bond energy and all. But again, you know, the difference would be very, very marginal. So when you are treating 2 iodooctane with iodine 128, the overall idea is to somehow bring a change by only changing the isotope of iodine. But this will happen in very few number of molecules. This will happen in very few number of molecules because iodide is replacing iodide. अरे हाँ ना बोलते रहो, ये नॉर्मल आयोडाइड दिया.
हाँ सर.
हाँ हाँ सर.
ठीक है. Now again, this is something which is very significant, as I told you, is scripted in most of the sources and is taken as a piece of history in proving that Sn2 causes inversion. You don't need to break your head too much into how the readings and the manner in which the values would have been concluded. You leave it largely to the optical instruments, but you can always find the rate of the process. There are several ways in which you can find the rate of the process. All right. So suppose you are able to find the rate of the process, and I don't want you to be loaded with too much of information. So even if I know some values here or there, I would want to avoid putting any data here. I would simply say, suppose the rate of this reaction is something like R1, the rate of the reaction. All right. Why R1? I would take it R only. Suppose the rate of the reaction is some R. This was optically pure. This was optically pure. बच्चे लोग हाँ ना बोलो, ये ऑप्टिकली प्योर था. और अगर इसका इन्वर्सन हो रहा है, तो सोचो अगर एक मॉलिक्यूल इन्वर्टेड हो रहा है, तो दो मॉलिक्यूल का ऑप्टिकल एक्टिविटी खत्म हुआ है. बिकॉज जब एक इन्वर्टेड होगा तो ये एक के साथ में रेशमिक बना देगा पेयर. यस और नो? अगर एक का इन्वर्सन हो रहा है और वो उसका नेचुरली एंसियोमर है, तो वो विच वन मॉलिक्यूल अंडरगोइंग Sn2 and one molecule getting inverted, two molecules will become racemic, two molecules will lose its optical activity. एक अगर उल्टा हो जाता है तो वो अपने एक और पकड़ करके पेयर बना लेगा. Somehow you are able to calculate the rate of the reaction, and you're also able to calculate somehow the rate of racemization, which is suppose some R prime. So these are things which you'll want to leave to some technical experts or to optical instruments, which will be able to tell you, one, the rate at which the process is happening, and two, the rate at which it's becoming racemic. And if this R prime is found to be exactly 2 times R, this means every molecule undergoing Sn2 is getting inverted. If this R prime is exactly equal to 2R, this means every molecule undergoing Sn2 is getting inverted. Because it's only if every molecule undergoing Sn2 gets inverted, the rate of racemization will be exactly twice the rate of the reaction. Are you understanding me? Have there been any qualms, or have there been any misgivings here? Then the rate of racemization would never be exactly twice the rate of the reaction. But when the rate of racemization is exactly twice the rate of reaction, it means with every molecule undergoing Sn2, it's an act of inversion only, because one getting inverted would render two optically inactive. So rate of racemization being exactly two times the rate of the reaction would mean every molecule जिसके ऊपर में I-128 हिट करता है, एसीटोन मीडियम में इसको करते हैं हम लोग. एसीटोन मीडियम में करते हैं. एसीटोन एक पोलर अप्रोटिक सॉल्वेंट है. Sooner than later I'm going to talk about protic aprotic solvent. So far so good, I believe. I think you are understanding me. You will want to move on. So चलो हाँ ना बोलो. I think everything which I told you in the last class on Sn1, Sn2 still fresh in your mind. You remember the mechanism? You remember Sn1 is one two-step process with a carbocatenic intermediate. Sn2 occurs by a transitory state, one-step process, mixing and breaking happening in the same step. All right.
हाँ सर.
Can I remove this clutter? अम्ब्रेला इन्वर्सन समझते हो? अम्ब्रेला इन्वर्सन समझते हो? मैं वापस एक पर्टिकुलर टेट्राहेड्रल बना करके उसको पूरा मिरर इमेज बनाऊंगा, तो इट्स लाइक द कैनोपी गेटिंग इन्वर्टेड. It's like the canopy of an umbrella getting inverted. Yes or no? You see an umbrella caught in a storm, although I've rarely seen it in real life. It's like the umbrella canopy getting inverted. All right. Walden inversion or umbrella inversion refers to the optical activity being inverted. More than the optical activity, I believe the nature of the special projection getting inverted, or the leaving group and the incoming nucleophile will obviously have opposite facets. Can I remove this clutter? बच्चे लोग हाँ ना बोलो. अब फिशर प्रोजेक्शन की जगह फिशर प्रोजेक्शन की जगह फिशर प्रोजेक्शन की जगह अगर यही चीज फिशर प्रोजेक्शन की जगह अगर यही चीज ऐसा एक रिंग में आएगा, तो रिंग में मान लो यहां पर एक ब्रांचिंग बनाया हुआ है और यहां पर एक और बीआर जैसा कुछ है, और इसमें अगर एक न्यूक्लियोफाइल डाल रहे हैं, Sn1 हो रहा है, यू आर सपोज टू गिव अ पिक्चर लाइक दिस. बच्चे लोग हाँ ना बोलते रहो.
हाँ सर.
हाँ सर.
हाँ सर.
And with another nucleophile Sn2, मैंने न्यूक्लियोफाइल का नेचर चेंज कर देता हूं, बिकॉज सेम न्यूक्लियोफाइल दोनों थोड़ी करेगा. अगर Sn1 होता तो वैसा बनता, ऊपर से भी लग रहा है, पीछे से भी लग रहा है, और Sn2 होने से इट विल बी एन एक्ट ऑफ inversion only. दिविज ऐसे आश्चर्यचकित होकर क्या देख रहे हो? मैं बहुत गड़बड़ कर रहा हूं. Now it's comprehensive, all of you happy with this? You know how to deal with it when it's given in terms of the physical projection, and how to deal with it when it's given in the wedge and half form. तो बेसिकली ये डोमेन ऊपर से लगा हुआ. अच्छा, तुमको एक बात और समझ में आता है कि ऊपर से लगा कि नीचे से लगा, इसके लिए मेरे को ना एक यहाँ पर और एक विटनेस का जरूरत है. समझ में आता है बबुआ? मेरे को यहाँ पर एक विटनेस चाहिए, उसके रेस्पेक्ट में ऊपर है, वो नहीं रहने से लेकिन क्या फर्क पड़ता है ऊपर है कि नीचे है? फिर हना नहीं बोलते हो.
हाँ हाँ सर.
मत छोड़ो. जितना प्रॉपरली रिस्पॉन्ड करोगे उतना जल्दी मैं पढ़ा पाऊंगा, उतना जल्दी तुम घर जा पाओगे. ये बात सबको समझ में आता है? यू कैन टेक लॉन्गर टू अंडरस्टैंड, नॉट अ प्रॉब्लम. आई हैव ऑल डे. Can we move on? You want me to repeat something from here? A bit about the real form of the six-membered cyclohexane. See, a cyclohexane is how we represent a six-membered ring. A cyclohexane is basically a regular polygon. You know, we end up drawing a regular polygon. That's the way we have been doing for cyclic compounds so far. Naturally, they are sp3 hybridized and non-planar. I'll tell you about the various possible structures at some point of time, but for the time being, the most stable form in which a six-membered ring exists is actually what's called a chair form. I could make it look a little shaded so that it appears like non-planar. Naturally, it's non-planar. This is the best I can do. And in the chair form, I don't know if I've told you about chair form or in the past or not. In the chair form, it's supposed to be the most stable because in the chair form, it's supposed to have least angular strain and least torsional strain. This angular strain is minimum because all the bond angles are very close to 109 degrees. It's three-dimensional puckered kind of a structure, and it has least torsional strain because the bond pair repulsion will be minimum. अब सारा कार्बन में दो दो बॉन्ड रहता है. नेचुरली नॉर्मली हम लोग दोनों हाइड्रोजन लिखाते हैं, यहाँ पर हाइड्रोजन हाइड्रोजन रहता है. यस और नो? बच्चे लोग हाँ ना बोलते रहो.
हाँ सर.
So all these six corners, which are no longer the corners of a regular polygon now, have two bonds. And let me call these two bonds. You know about it? You know about these two bonds? So there's supposed to be what's called an average plane of a non-planar structure. Even if it's a non-planar structure, there could always be an average plane. What is the average plane? The average plane or the reference plane of a non-planar structure is the plane where it will cast its largest shadow. Getting me? With every three-dimensional structure, you can have a plane upon which it will cast its largest shadow. Now, when you say it's casting its largest shadow on a given plane, this means maximum plane particles on its surface are akin to that plane, aligned to that plane. All right. And even if you don't dig that deep, even if you don't go that through, let me tell you, if there is an average plane to this non-planar structure, all the bonds which are on that plane are called equatorial. And the ones which are perpendicular to that plane are called axial. Maybe I'll want to make the axial look different. And I don't know if I told you in the past or not. One way to identify axial would be. I don't remember if I've told you in the past or not. जहां पर ये नीचे जाता है ना, एक्सियल नीचे जाता है. जहां पर ये ऊपर जाता है ना, एक्सियल ऊपर जाता है. जहां पर ये नीचे आता है, एक्सियल नीचे आता है. जहां पर ये ऊपर आता है, एक्सियल ऊपर आता है. जहां पे नीचे आता है वहां एक्सियल नीचे आता है, जहां पर ये ऊपर आता है वैसे एक्सियल ऊपर आता है। तो ये आसान तरीका एक्सियल और इक्वेटोरियल को याद रखने का। जहां पर ये नीचे आता है एक्सियल नीचे आता है। फिर हाँ ना नहीं बोलते हो। And when you see the Newman projection, what is Newman projection? Newman projection is when you see all the bonds along a carbon-carbon bond. When you see the Newman projection, you see it with respect to any two carbon, you'll find the equatorial and axial being oriented in a manner that they're completely staggered. They're completely staggered. And because they're completely staggered, the bond pair repulsion is minimum. And because of minimum bond pair repulsion, you claim to have least torsional state. बच्चे लोग हाँ ना बोलो।
हाँ सर।
And for the stability of a six-membered substituted ring, in a substituted ring means there is a group other than hydrogen attached to the six-carbon ring. The bulky group or the bulkier group should always be kept equatorially. It should always be kept equatorially. It should always be kept equatorial. I repeat, a little bit about the chair form, which is the most stable conformation of six-membered ring, which is supposed to be the most stable cyclic form of carbon ring. You know, six-membered ring is more stable than both five-membered ring and seven-membered ring. I have told you how to identify the axial carbon and axial bond and equatorial bond. And I'm also adding to the set of informations that if it's a substituted ring, you will want to keep the substituted group, the bulkier group, always equatorial. फिर हाना नहीं बोलते हो. You can take your
हाँ
time.
सर।
You're understanding me? You're happy with this?
हाँ
Now
सर।
let me take you to a situation where you have a bulky group, which is an alkyl group. Any group other than hydrogen would be bulkier compared to hydrogen. Yes or no? And you have an X here as the leaving group, which I'll call as the corresponding cis isomer. And at 1,3 position, if I look for a cis substituted ring, you can choose your own 1, 2, 3 because eventually all positions are going to be equivalent. Suppose I choose this as 1, this as 2, and this as 3. I would want to have the bulkier group equatorial. Yes or no? So if this is above, this is also above. And if this is above, it's also above. And I'll get both the equatorial positions. Yes or no? So can I say this 1, 3 cis and there could be a 1 equatorial, 3 equatorial or a 1 axial, 3 axial possibility, where naturally this possibility will be much more stable and thereby explode in more number of molecules. दोनों ऊपर या दोनों नीचे एक ही बात है. मतलब अगर मैं ये 1, 2, 3 लेता, मैं अगर ये 1, 2, 3 लेता, अगर मैं ये 1, 2, 3 लेता, तो मैं दोनों इक्वेटोरियल लेता, दोनों इक्वेटोरियल नीचे होता है, यस और नो? तो 1,3 में सिर्फ में दोनों ऊपर या दोनों नीचे करके मैं इक्वेटोरियल इक्वेटोरियल ले सकता हूं। 1E3E या 1A3A both happen to be cis geometry, yes or no? But when it's one above and one below, which I refer as trans 1,3 substitution, and now if I go about drawing a particular shear form, again you could take 1, 2, 3 according to your convenience. Suppose I take 1, 2, and 3. All right. I want this to be equatorial, which is below. Yes or no? And at position 3, because this is trans, ये अगर नीचे वाला हो तो ये ऊपर वाला हो जाएगा, yes or no? Which will mean I'll either have a 1E3A or a 1A3E arrangement. They'll have comparative stability, but both will have lesser stability than a 1E3E, which could be found in a cis structure. बच्चे लोग खाना बोलो, इसमें देखो कुछ भी चैलेंजिंग नहीं है. It's like a new set of things which you'll want to learn, in absence of which you'll not be able to manage questions of this kind. The question will be simple between this cis form and this trans form, which will be more reactive for Sn2. Between this 1,3 transform and 1,3 cis form, 1,3 cis form and 1,3 transform, which will be more reactive for Sn2. Transform, because the cis form you have already got 1E3, a transform and a 1E3 will become 1E3 because वहां पे inversion होता है ना. A transform would rather want to become a cis form via Sn2. Yes or no? Obviously, if it comes, it will come only in an exam like JEE Advanced. And you need to have this clarity of thought. It took me longer maybe to explain this to you because you're learning it first time. But when you are given a problem at hand and you identify which is axial, which is equatorial, maybe with a little peace of mind and with some calmness, you will want to approach these two geometrical isomers and realize that in Sn2, because inversion happens, the trans form would want to become the cis form. Yes or no? Because at position 1 and 3, if I look for both equatorial at position 1 and 3, see if I look for 1, 2, 3, दोनों नीचे वाला होना चाहिए. If I look at 1, 2, 3, दोनों ऊपर वाला होना चाहिए. If I look at 1, 2, 3, दोनों नीचे वाला होना चाहिए. Yes or no? So a cis 1, 3 form is more stable. A cis 1, 3 form is more stable, and a trans 1, 3 form would be more willing to participate in an Sn2. So चलो हाँ ना बोलो. So I would write trans 1, 3 is more reactive towards Sn2 because it will want to become a structure like this. X माइनस जाएगा, Y माइनस आएगा और इन्वर्सन होगा Sn2 में, तो वो ट्रांस हो जाएगा. फिर खाना नहीं बोलते. What do you think for say a 1-4 form? Cis, trans, which is more reactive towards Sn2. 1-4 है, ये 1-4 है. Cis, do it this way. You take any 1-4 position. 1, 2, 3, 4. Suppose you take this position and this position. And look at the 2E. Are they cis or are they trans? ये नीचे तो ये ऊपर है, तो ये तो ट्रांस है ना. ट्रांस वाला ज्यादा स्टेबल है, वहां दोनों ही मिल जाएगा उसको. फिर खाना नहीं बोलते हो. और कोई 1, 2, 3, 4 ले लो. ये 1 ले लो, ये 2 ले लो, ये 3 ले लो, ये 4 ले लो. इन दोनों को देखो, दोनों ही क्या है, ये अगर ऊपर वाला है तो ये नीचे वाला है. तो ना एक बार ये क्लैरिटी रहेगा, यू अंडरस्टैंड बिटवीन सिस एंड ट्रांसफॉर्म. द ट्रांसफॉर्म इज more stable, which will have higher heat of combustion, which will have lower heat of combustion. Suddenly it will become a problem of thermochemistry. The one which is more stable will have lower heat of combustion. Between cis and transform, which is more stable, suddenly it will become a question of isomerism. Between cis and transform, which will have a higher rate for Sn2, it becomes a question of general organic chemistry or reaction mechanics or haloalkane. All you need to do is know about this basic arrangement of bonds in the chair form, and trust me, everybody is not good at it. If you keep things simple, you will be able to solve questions in chemistry with unparalleled ease. You just need to know the approach. अब सीधो ट्रांस आएगा, तुमको खाली ये देखना है 1-2 पोजीशन, 1-2 पोजीशन, ये नीचे ये ऊपर है. 1-2 में मेरे को ट्रांस पोजीशन ज्यादा स्टेबल मिलेगा. 1-3 पोजीशन, ये नीचे ये भी नीचे है, मेरे को सिस फॉर्म ज्यादा स्टेबल मिलेगा. 1-4 में ये नीचे ये वहां ऊपर है, मेरे को ट्रांसफॉर्म ज्यादा स्टेबल मिलेगा. तो सिस फॉर्म ज्यादा रिएक्टिव होगा फॉर Sn2. दिस इज मोर स्टेबल, दिस मोर रिएक्टिव फॉर Sn2. यस और नो? Any idea about Sni? Anything which you can tell me about Sni? हाँ, रिएजेंट क्या है? थोड़ा सा भी याद है अगर तो. रिएजेंट क्या है? People know so much about iPhones. Time to know about Sni. See you next day. Come prepared. Sni and NGP is what I'll take next day. NGP is neighboring group participation. ये किताब में नहीं मिलेगा सर, कब मिलेगा मैं पढ़ाऊंगा, चिंता मत करो, पर ऐसा नहीं थोड़ा पढ़ के आना. चलो बच्चे लोग, stay happy, stay healthy, have a great day. And I'll see you tomorrow 8 p.m. in an online class where I'll be solving all questions on the solubility product and chemical equilibrium. I think you've already seen the sorting I did. I gave you a soft copy of the problem sheet now. Towards the end, I've sorted the questions. Solubility product का और chemical equilibrium का वो सारा देख लेना. कल 8 बजे से देखता हूँ क्लास.
Okay,
क्या
sir.
बोलते हो? Evening 8:30. देखो ये जो क्लासेस है ना इनमें एक्चुअली मैं क्लासेस लूंगा जेई एडवांस का सारा क्वेश्चन सॉल्व करवाऊंगा जो लोग अभी जेई एडवांस देने जा रहे हैं. So some of your seniors would be there in that batch as well. But that would be a fluctuating crowd because so many of them would be stuck up with their board exams and this and that. And I don't want duplication of effort. So now I would be inviting everyone, class 11, class 12, 12 pass, problem solving session, let's solve problems together. Let's find out the easiest way of doing problems. I'll do that tomorrow 8:30. I'll also give you a hard copy of the questions on mole concept today and an assignment on Sn1, Sn2.